and we are happy to even know that.
మైక్ ఉందా? Or thermal analysis purpose. Both you can contact me. Okay. How many of you are faculty? Yeah, I am faculty, so I will raise hand. So few. PhD research scholar or a postdoc research scholar. So most of you are most. Then PG students. Okay. UG students. UG students also there. Okay. Both you can. Anybody 10th class or 12th class? No. So UG. Okay. So next 1 hour or so, we will take you through this thermal analysis. We all know thermal means temperature, and we know that many times we misunderstand between all thermal techniques, but all are not same. Okay, there are some differences, but let us go through. Before going through thermal analysis, let us start with very basic. This is we will go through characterization technique and do's and don'ts and the challenges and suggestions. So this is a workshop talk, so slightly different than the theory talk. Of course, we are going to have only theory, but very close to the practical. So we will have, let us start with telling that what is chemistry is about, or what is material science is about. So we generally say making and breaking bonds. Okay, What it means, we would like to synthesize new compounds or new materials, and we want to understand their properties. But once you synthesize, how you know that whatever you wanted, you got it? So that's where characterization came into picture. So unless you characterize, you don't know what you wanted, the same thing you got or not. So before synthesis, one more thing is there, which is not in the text. It is only in the mind. It's not on the paper. Design. So people use for design either experience or literature or computational methods or AI nowadays. So design, synthesis, characterization. Before characterization, one more key step is there. Anybody remember? Purification. Okay, so design, synthesis, purification, characterization, and why we synthesize, we want to understand their properties. So then properties, why we need to understand properties? For desired application. So if you see again the series, design can be through experience, through literature, or through computational, through AI. Synthesis, it's hands-on experience, making and baking bronze. Then purification, then characterization, then studying or understanding the properties. Properties can be of their pure state or their mixtures or under the influence of something else. Maybe under the influence of temperature, pressure, composition, application, then it's the benefit for the society or the industry. So this is how the chemistry or the material science make impact on the society and industry. Today we are going to talk more on characterization techniques. Why we need to characterize. So to understand the structure very well, to understand the composition, to receive the desired properties. For all these things, better understanding or better characterization techniques also will help you. Now, if I ask you a question, why one has to characterize? We came to know, we are sure that what we wanted we received. Why we need to characterize? To identify or to get the confirmation or to get the confidence or to get the feeling that yes, I got what I wanted. To identify, and characterization also will tell you what kind of compositions are there. I know 2-3 things are there, but how much composition? I don't know what are the things are there, so I will come to know. So to quantify, to know the quantity or to know the composition of individual either atoms or molecules or something else, is and it will also tell you how pure your compound or how impurity is there. What kind of impurity is there, that also you can find out. But at least to know, purity is also very important. Let me ask you one thing. Any product we are buying from the market, any product, the highest cost is due to what? Highest cost, what we are paying for the product, is due to what? So you have to guess. I will give you option. 1, raw materials. 2, the process of making it, synthesizing it or making it. 3, marketing or advertisement. 4, transport. Or 5, the commission for all the people involved, different stage. So many may say raw material, many may say synthesis, many be done and how accurately you can get the results. One is a temperature change, other one is either weight change or the heat change. The smallest temperature change you can measure and the smallest weight change or heat change you can measure, the instrument cost is high. DSC can be of 1-2 lakh, DSC can be of 75 lakhs. Differential scanning calorimeter. TGA, thermogravimetric analysis, can be done for with the instrument can be of 3-4 lakhs, instrument can be of 75 lakh or 1 crore. What is the difference? Thank you. What is the difference? How small change in temperature you can measure precisely, how small change in weight or heat you can measure precisely. This is what it is about. Okay. So thermal analysis is a branch of material science where the properties of the materials are studied as a change with the temperature. So let's say I want to say this boy is good boy. Okay, this student is very good student. What it means? It means reference to somebody who is not good as him or her. You getting my point? It's a comparative. So with whom we should compare? Compare with the ideal student. Side ideal or a calibrated or the reference. The reference is the highest credibility in physical chemistry or in chemistry or in material science. What is your reference? That matters a lot. When I say I am intelligent, I have some reference in my mind. When I say I am handsome or I am beautiful, there is something reference in my mind. When I say I am rich or poor, what is the choice of your reference or standard or calibrated? That matters a lot. We say standard. Thermometer, when we say graduated or this one, certificate will be there, no? In India, we have what is called ISI. That certificate, NIST, that certificate cost is very high. You have a thermometer, non-certified, thermometer certified. Exactly same working principle, same thing, same. Cost would be maybe 10 times different. Because somebody checked. You are BSc, MSc, PhD, everything, you have all the qualification for the job when you apply. But still they ask you 2 reference letters. There might be something missed. You cannot quantify the quality. So there is a opportunity to tell more about you. No, in India, but abroad they take it very seriously, reference letter. If I write excellent for some guy and he couldn't or she couldn't be excellent there, my reference letter will be not valid for that institute for several years. They take action also. Or they inform my institute head of the family, director. You see, your faculty gives reference letter for this guy who found responsible for an accident in the lab. He doesn't know even basics of chemistry. My reference letter for that institute gone. Why reference is very, very important? Because we consider that as ideal. The choice of the reference is very, very important because according to the, here in this instrument, so to avoid all the discrepancies, we will say nothing is reference, means empty. We will have same kind of 2 vessels and put it and then empty. So what we are doing, changing the temperature, how much changing we should know, okay? And that change, as small change as possible, should be able to quantifiable. What is the lowest temperature range you can, let's say I have now 30 degrees Celsius. How much I can increase? 32. From 30, What I can increase the temperature? Tell me. Let's say this water bottle, I am now flowing. How much temperature I can increase? Or let's say I put a candle and heating. How much temperature I can increase? Any idea? I have a thermometer measuring. It depends. The lowest heat change you can measure is the least count of your thermometer. Thermometer's least count is how much? Depending on 10 and 11, between how many lines are there. If 5 lines are there, 0.2. If 10 lines are there, 0.1. Digital thermometer. Digital thermometer. Depends. What is the least temperature change you have heard? Anybody? 1 degree change you have heard? 0.1 degree change you have heard? Less, further less? Who are checking mobiles? What is the least temperature? Wrong answer is allowed. Bolo. Last row, that 3 girls, 4 girls. Bolo. What is the least temperature change you have heard? Lecture khatam, close ho gaya, chalo. Neither you are answering. I say wrong answer is allowed. Wrong answer is allowed, Amma. At least, see, I told you, last bench one, nobody should sit. I asked question. That time you were not there. Huh? Either answer it or you change the last row. Either answer or you change the last row. Chalo, last 4 girls and 1 boy, 2 boy, 3 boy. Okay, 7 people has to answer wrong answer. Otherwise I will tell the organizer no certificate for those 7 people. This is my last lecture. They will never call me now. I've heard. Boy, at least you say yes, no, maybe. I don't know. I don't want to tell. And if I am audible, last 7 people. 1, 2, 3, 4, 5, 6, 7, huh? Arey baba, raise karo. Okay, not a problem. Okay, so measuring change in weight, change in heat, or change in something else, and that's how it is thermal techniques. So in every thermal techniques, temperature is involved. So in differential scanning calorimeter, heat flow changes versus temperature or time. So you have third thing. If your temperature change is constant, dt by dt. First T is capital T, second T is a small t. dt by dt, change in temperature versus change in time. If it is constant, okay, then we will see what is happening. dt by dq. Q is heat. In thermal analysis, temperature difference versus or time. In TGA, temperature difference or time difference versus mass. How much mass is changed? People say, what is the difference between mass and weight? Anybody knows? Weight and mass. So weight means it involves the correction for the gravity. We assume that mass is constant irrespective of gravity. Okay. So most of the time mass word is more accurate because it will not depend on your laboratory on the hill or the ground or underground. So that's what we want to make contact. Now we will see today little bit about TGA, where you see mass change. DTA we will not see much, but I have a couple of slides. And DSC we will see. Other things are there, but we will not. Today things have been changed. Nobody wants to enter sample 2 times. Everything at a time I want. TGA MS, TGA DSC. You insert sample once, it degrade How much degrades also I want to know. What are the degraded products also I want to know. And how much products are there, that also I want to know. TGA, MS, MS. So that much advancement has happened. And all of us tells that lab space come hai. We don't have much space. Everybody wants compact. Compact, faster, robust, accurate, user friendly, cheaper. कुछ और चाहिए? Yeah, that's a business. That's how it works. Either you take any kind of DSC or any kind of TGA, principles are very, very common. These are the only 4 major components. 4 main things will be there. Actually, when it is too small, no, people won't pay. So they purposefully make it slightly bigger, and then they say, sir, if you want compact version, it would be a charge more, and then they make compact. What are the major components? One, where we have to keep sample and heat. There should be a chamber where we put sample and we heat it. What are the common sense tells? Hey, this chamber should not be interfered by the outside temperature. So it should be isolated. Yes or no? And the sample should be minimum. You cannot take, if I ask you to measure TGA, can you give 1 kilo sample? 1 gram? Maybe no. 10 milligram? Okay. So, furnace where you have a sample chamber and heating facility, and programming, how much you are heating you should know. Isn't it? How much, what rate you are heating you should know. So programming, in that higher temperature, it should able to perform either heat change or the mass change. So there should be a thermal balance. What is the loophole or what are the challenges here? What are the challenges here? Let's say, sir gave me lakh rupees as a travel fare of all of you. Please collect your bill and pay you money. I am the mediator. Sir has a job, he left. So I take your bill one by one. Okay, 1252. Madam, 2 rupiah nahi hai, 50 le jao. Slowly I started giving you 2 rupees less, 10 rupees less, and then finally I started rounded off. 1250, round figure is 1000. Jao. Taking. Will it distribute? No. This should not happen. So here you have put sample hawa mein to nahi latkega na. Where is your sample? You are keeping sample somewhere, no? It won't be floating in the air, no? The pans, what is the properties of the pan? What do you expect from the pan? Let's say you put your money in the bank. What do you expect? Either money should be safe, nobody should touch, and I should be able to take as much as I put. But they charge. At least we know the charges. It should not be hidden charges. What is the pan? You tell me. What is the pan? You put a sample there. Common sense. Nothing. Sir, I never studied TGA. This is the first time I am studying, sir. Nothing to do. I am asking common sense. The pan should take heat and give to the sample. How much? Whatever amount it takes. It should not keep anything. It should not cry why I am getting heated. It should not have its any identity. Its job is to hold the sample and reflect whatever it is getting. No emotion. No commission. नो प्रमोशन, ये बेचारा थोड़ा धीरे धीरे हीट हो रहा है और थोड़ा ज्यादा देते हैं, चलो जाओ. Ideal pan is like ideal, that's it. Coming, not coming, not going. You agree? Anything extra the pan does, it's an interference. Your result will be wrong. If system getting cooled, sample should be cooled so quickly. That's how the pan should behave. Pan is holding the sample, that's it. I am not responsible for anything. You getting my point? So what is this pan made up of? Anybody idea? सिल्वर थोड़ा महंगा होता है, प्लैटिनम और महंगा होता है, क्वार्ट्स, and the thing is, and then your balance, you're working at 1500 degrees Celsius, balance should behave like a whatever the way it behaves at 50 degrees Celsius or 5 degrees Celsius. And that's where the challenges are there. Okay? And that's where the cost of the instrument we are paying. Robustness. The interference of the temperature on the property should be as minimum as possible. Or at least it should be predictable so we can do the correction. So major things are furnace, programming, balance, and the data acquisition. Whatever complication happening inside, I don't care. I put sample, I want result. Yes or no? As a user. So data acquisition system should be, so you should get all the data. Sample you put, by mistake you have done, instead of 10 milligram, you have taken 9.5, it should measure. It should say your initial sample weight is 9.5 milligram. The temperature scanning rate is 10 degrees Celsius per minute. Your temperature run for 3 hours. Your temperature changed from room temperature to 1500, and the scanning rate was this, heating rate was this, your mass loss was this. All plots should come. Weight loss versus time, weight loss versus temperature, weight loss was this, weight loss was this. And then you see, hey, sudden jump happened. What happened? It's a moisture. So you will know the purity of the sample. So this is how it looks. I am not promoting TA, but this is how one of the instrument looks, where you have inside sample. So you have a inlet and outlet for your what you call water bath or other oil bath to maintain the temperature, and you can see the results here, and you can apply external pressure if you want, or all these things. And this instrument can run up to 1200 degrees Celsius or up to 1500 degrees Celsius from the room temperature. And the sample requirement is 50 milligrams. The cost is close to 60-70 lakhs. EGA usually measure weight loss. Very few times you can measure weight gain also. I am heating. It is start, it doesn't want to go. If it is settle again, your results will be wrong. You're getting my point. Sample degraded little bit. The degraded product again settles down, there is a problem. We want to discard them. How you will discard? There is a carrier gas, flow gas. That gas usually nitrogen. So the flow rate matters, how we are discarding matter, and what are the pan's property? It should not interfere, but it should be only facilitator. What is the carrier gas? It should not interfere. Carrier in such a way that it will take sample also along. Carrier gas should not interact with the materials. Then it's wrong. Carrier gas should be very slow going. It's not even doing its job to take away the degraded product. Then it's also wrong. But where it is gone, hey, I don't care, sir. Bye, it's stuck somewhere and the next sample will be a problem. In 1 month, your instrument is gone. No, sir, my guide purchased. I have no problem. Sir, how long this should run? 5 years, sir. I will get PhD, I will go. It's not the way. But where it is going? Take the degraded product out without interfering with the instrument and the analysis. Thermal TGA and dynamic TGA we will see. We will see, and measuring TGA will measure the change in weight, mostly reduction in the weight by increasing the temperature. So 2-3 things are in our mind. One, 2 pans are there. One is empty, which is our reference. Another one, we put the sample. Temperature is increasing. Weight, temperature increase, weight decrease. The increase in the temperature is a specific rate per degrees, or let's say per minute 10 degrees Celsius or 10 degrees Celsius per minute. So time also we know. Weight change. So if we know weight change versus time, kinetics will come in picture. Weight changes with temperature, thermodynamics will come in the picture. These are the few experiments where you can do thermodynamics and kinetics together. You getting my point? Temperature increased, weight decreased. Now, this is how fast or how slow decreasing or how long this sample is sustaining, that will tell you about your materials. Stability of your material against the temperature. See, and how we will draw. So, TGA will tell you many things. One, thermal stability of the material, how robust it is. Let's say you want some material in aviation. That means it should sustain for the pressure. If you are using some material in the furnace, it should sustain temperature. Okay. So thermal stability of the materials, oxidative stability of the material, whether it oxidizes fast or not, if you do the sample in presence of oxygen, composition of multi-component system. How we know? So the weight change of this sample, when if it is a mixture, you will know there is a characteristics of each samples, though it is in the mixture, and that you can identify the pattern. The decrease, it's not a simple decrease, in a pattern way you decrease. Okay. Estimated lifetime of a product means how long it can sustain. Decomposition kinetics, kinetics came into picture here. If your heating rate is constant, then you have a time change also. So how fast or how slow it is decomposing along with the time when the heating rate is maintained. So you will understand kinetics and the effectiveness and the moisture volatile. How you know moisture and volatile content? Let's say your sample's decomposition temperature is 600 degrees Celsius and you took 10 milligram sample. Suddenly after 80, you started decreasing at 110, 10 milligram sample become 9 milligram. And from 110 to 400, nothing is happening. Flat. That means your sample's characteristic is to stable up to 400 plus degrees Celsius. Then what is the weight loss at 82? Your sample purity, you will find out. How much impurity? 10% you find out. So thermal stability of the materials when you decompose and all this thing. Anyway, our carrier gas, if you put oxygen, you will find out something else. I'm not going into this detail. Let us see some of the thermograms. How it works. Let's say if your TGA is running up to 1500 degrees Celsius, which balance will work at 1500? Wiring. All wires should be stable, isn't it? Your pan should be stable. If your material is stable up to 1500, entire instrument should be stable, no? Otherwise, that your instrument is not stable and you heat it, and after one experiment, your entire instrument will melt and become one ball. happen, no? So they put a cutoff at least 40 degrees Celsius below the instrument's capability. You cannot go beyond. Otherwise, your instrument will get damaged. It won't function like earlier. कुछ टेम्परेचर बोल दो डिग्री सेल्सियस में 15 डिग्री सेल्सियस वो तो बहुत ठंडा हो 50 डिग्री सेल्सियस नेक्स्ट सो इफ यू रन द मेस इन द डॉक्यूमेंट इज सो इफ यू रन द मेस इन द डॉक्यूमेंट इज रिटन sambar should be minimum 50 degree Celsius in the container. When you pour it, it should reduce. If it is 50, you cannot eat. Isn't it? So it should, so our hand, similarly, the instrument should sustain beyond 1500 Celsius. Isn't it? And that's why our balance should work. What kind of balance will work at 15 degrees Celsius? So we have an electrical balance. There is no real balance. So we have a null point balance where weight loss, weight change happen. So this pan will go down. So as the pan will go down, some additional electricity or current will be applied to bring it to again neutral. Amount of current applied to bring to the neutral, then they say converted into weight. Oh, if you apply this much current, that is equivalent to this much weight. That is a minimum current applied and minimum weight you measure. That's how it works. Not real balance. Use the balance is gone down. Position unequal amount because this and this is not equal. And the light shine on the two photodiodes, and then current is then applied to the meter movement to return the balance to the null position. So how much current you apply to return to this null position means straight position. The amount of current applied is proportional to the weight loss or weight gain, and that's how it will be calculated. This is we should know. So that photodiode or the light and then current applied is the key. Program, what is written? Analysis of TGA data. Sample, anybody know the sample name? Last 7. You still have time to change the position, okay? Last 7. What is the sample name? I will flash this light and you read. Can you read? Anybody can read? Polytetrafluoroethylene. Anybody from 4 girls? I will flash light and you, yeah? Okay? 10.3 milligram. What is my heating rate? Who will read the last one? Huh? I will flash this pointer and you read. Huh? Minute. What is the carrier gas? Who will read? This much I shouting. Nobody is telling, sir, I will read. Don't worry, don't shout this much. They won't care. अरे आया है उसको पैसा मिलेगा इधर. You will flash and you read. Okay? Nitrogen. What is the flow rate of the carrier gas? 50 ml or 50 cubic centimeter per minute. Now, I got all the information. So my sample is this, polymer size is this, and I'll simply ask. I started at 400, finished at 650. How much time my analysis took? How much time it took? Calculator is mobile. You take mobile. If you put rate, you twist it. It will become a smart calculator. Calculator allowed. How much time it will take? I'll take some water, okay? Last, sir, I'll go there. Sir, certificate everybody will get? Huh? Everybody will get, huh? Wrong answer is allowed. What is the question? What is the question? How much time my analysis took? Time. You tell me in minutes, not in days or years. I'll go and see them, huh? They are thinking that sir will not come. Calculate, Amma, calculate. Phone allowed, calculate. Good. 50. Calculate it. Not allowed. You will, oh, sorry. You are from which college? How much time? Anybody got 50 minutes? They got 50 minutes. Please clap for them. All of you, please clap. Yeah. How they have calculated 50 minutes? No notebook, huh? Ayyo. Notebook is not there. They didn't give notebook. She came like a katha. I am a Rama and I am a Pandit. I am Pravachan is going and she is listening. Appa, notebook is ille. Huh? Notebook ille. How much time? How to calculate, Amma? Certificate confirm. That's the reason. Calculate, Appa. How to calculate? You see the temperature difference. 650 divided by the rate 5. 250 divided by 5. That many minutes. Isn't it? Sir, ऐसे कैसे यार? अभी after my katha over, we will distribute prasadam, okay? अरे बाबा, they think that I am here for. So it's. अरे बाबा, they think that I am here for. So it's simple, no? It took less than 1 hour. So 1 thermogram, how much information it is giving? Is sample pure? Sample is pure? Because nothing is degrading. And simple. Is it a mixture? No. It's a one component. How I know? Because I see only one hump. Is it pure? Yes. Because it's not anything is noise is there. What could be the decomposition temperature? There are many decomposition temperature. People say T10, T50, T95 or something. Usually if nothing is written, T50 is the answer. What is T50? Weight loss about 50% and that temperature is TD. What is TD? Decomposition temperature. Okay. What is TD here? It is a 10%, I think. So T10 is 537. The midpoint is 562. So it depends what you write. Okay, it depends what you write. 100 means how much? 100 means how much? 10.3. 50 means how much? 10.3 divided by 2. You getting my point? 100 means how much? 0 means how much? 0. Generally, let's say, don't scare, okay? Nobody should scare. I am just for experiment purposes. I will not die so easily. I died. And they are heating me. What will happen? Something will happen. It's scary, no? Don't get scared. Okay, further heating, further heating, further heating, further heating, further heating. Will my weight today, I'll tell little bit less, okay? 60 kilo, which is wrong, okay? 80, reasonable, still low, okay? 80 kilo of my body, how much it will become? 0 it will become? No. Because ash will be there. So getting 0, any sample is almost impossible. Leaf you take, leaf, 10 leaves I took. Heating, 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 heating. So, dead weight because of the carbon or something. So 0 it will never happen, but there will be something always will be there. So, and what is this weight loss? You have to just see the pattern. Now we will see another example. Only 1 by 1, okay? All the time y-axis is mass decrease, not increase, and the x-axis is temperature, not to the scale, but 1 by 1 we have to see. Okay? What is the temperature range? I didn't write, so let us assume 100 degrees Celsius to 1000 degrees Celsius. It's arbitrary. What is the mass change? 100% to 0%. Only one line you see. Only 1 by 1 you have to see. Now I see A. When I see A, nobody should see B, C, D, E, F, G. Okay, only A you see. One line you tell. What you understand? In the studied temperature range, sample is stable. no decomposition is happening in the studied temperature range. Sample is stable, sample is pure. How many seconds I told? Sample is stable, sample is pure in the studied temperature range. Now, don't see anything, only see B. Some small decrease happening and then initially there is some weight loss. However, after that, until long temperature range, sample is stable. It means initial weight loss might be due to impurity, maybe either solvents or one line tells how many things. Okay? Now you see only C, nothing you see, only C. Sample is stable, decomposed, only one decomposition curve, so likely to be the pure sample, and then sample will lost entire weight. Maybe pure compound, single compound. Okay? Now you see D. Stable, reduced, stable, reduced, stable, reduced, stable. It's a multi-stage decomposition, might be mixture of many things. Or if it is a pure component, at each stage something is getting released with the huge mass. We will take one example of that. E. Stable, reduced, stable, reduced, stable, reduced, stable, reduced, stable, reduced, but no clear distinction. समझ में नहीं आ रहा है प्यार करता है कि नहीं करता है. What could be the reason? You are in very hurry. Heating rate is very high. If you slap one and ask दर्द हो रहा है and give pause to him to answer yes or no, but you keep on hitting. Hey, you're getting pain. Before you answer, again slap. What will happen? You have not given a time to respond. So, it could be multi-stage decomposition, but heating rate is faster, or not so many intermediates, or some problem with the instrument, or heating rate. Now, F you see, F. This is a miracle. Generally, it won't happen. With heating, temperature raised. With temperature raised, weight raised. How come it is possible? See, you took some weight. It's not like a bank, it will give you interest. The reason is carrier gas. वो कुछ किया है. So the carrier gas interact with the sample and make additional products and settle there. So Maji, the sailor who supposed to make you cross the river, you are in the boat. That Maji or the sailor only push you into the river. Something like this happened here. Now what is G? This is further rare. It will never happen, this kind of thing. It's very, very rare. So initially, your carrier gas interacted and weight increased, but that increase in the weight or that new product sustained for some temperature, and then it started decomposition. Okay? These are the only patterns, or most likely you will get this kind of patterns only in the deformity. So now you know all TGA curves. Let's take an example. Calcium oxide, I am taking now example of D. This D example I am giving. Okay? Calcium oxalate monohydrate. To heat, you see how much sample I took, anywhere written? Nowhere written. Okay, this is a calcium oxalate monohydrate. You heat it first, you will lose temperature, then it is stable, again heat it, you lose carbon monoxide, it's stable, again heat it, you will lose carbon dioxide, then this is the one. So First stage, calcium oxalate monohydrate become calcium oxalate, water vapor will go away. It is 50, 100, 150, 200. So it's around 100. It is 50, 100, 150, 200. So it's around 100. But I don't know, sir, exactly how much it is. This is around 500. Sir, I don't know exactly how much. This is around 650. But I don't know. How much time we have? 5 minutes? 10 minutes? 5 minutes? Yeah.
10 minutes.
10 minutes, okay. So, I don't know exactly. Then, green you see, now you see the right hand side, derivative. What is that? dg by dt versus t, or dw by, dw is what? Change in weight per change in temperature, again per temperature. So, you take derivative, you will get, so data is same. Weight loss versus temperature is green and this green line. The second derivative is blue and this blue line. Same data. This plot and this plot is same. So if you see this curve where it is lost is this sample. So this temperature is exactly lost. Wherever this loss is exactly this sample. Wherever this loss is. So now this is second derivative. Can you see this small change here in this? And that amplified here. Getting polyvinyl chloride, polymethyl methachloride, polytetrafluoroethylene indole. I don't understand, sir, what is in this, nothing is there. What it means, here, decomposition is so fast. Until here, nothing happened and here decompose. So it shows the stability, though your polymethyl methacrylate is stable, but when it reaches close to the TD, it suddenly collapses. It's like a kid. You are making chocolate चाहिए नहीं, chocolate चाहिए नहीं, हंसता है but chocolate चाहिए नहीं. Once it reach flash point, you before you ask chocolate चाहिए, you will cry so loudly. It has certain capability of maintaining under the temperature. So that it tells. We will say now what we understood, bond should be inert. It should not have its own identity. Whatever temperature instrument can go, bond should withhold at least 200 degrees Celsius more. It should not have any emotion, promotion or omission. Take, give. 1 crore, take 1 crore. 1 rupee, take. When somebody give 1 rupee, you should not cry or you should not laugh. Okay? It's just ideal. Take, give. Don't even look at. It should not interfere. It should not involve. How fast and how slow. Purge gas, how slow. Purge gas should also not interact. Okay? And the sample, how much we should take. Let's say my results are not coming, I take more sample. Not coming, I take more sample. Take. Will it come better? Will it come better? Now I have 3 questions. How fast or how slow should be the purge gas? How fast or how slow should be heating rate? How less or how more the sample should be? These 3 questions answer we will do and we will close. Okay? Amount 4 times experiment has done one student, same instrument. Same sample, same amount, same instrument, 4 times has been done. Polytetrafluoroethylene 10 milligram, 4 times experiment done. 4 times heating rate was different. Once it was 20 degrees Celsius per minute, 10 degrees Celsius per minute, 5 degrees Celsius per minute, 2.5 degree. When close to the right, out of 4. Any one, no? Not all 4. Now what happened? If you heat suddenly, what will happen? There would be a what you call thermal gap. I want to heat from this corner and I want heat should be uniform. I started heating very fast. Let us assume it is not burning. So its temperature here is very large, that is moving. If the flow is this corner, it will move here fast. What will happen to this corner? Lag will be there. So fast heating generates thermal lag, and you slapped, asking are you okay or not, slapped another, are you okay or not, slap another time. You don't even realize you are in the soup. You are in the soup. Hey, he seems to be okay. 4 times more, 20 degrees Celsius per minute and 2.5 डिग्री सेल्सियस मिनट. वहां तो 1 डिग्री होने में इधर 10 मिनट्स ज्यादा हो लग जाएगा. सो इट्स स्लो. इट डिपेंड्स हाउ मच टाइम यू हैव. Purge gas is going more, power is going more, electricity is going more, person is sitting more, but you will get a better result. 20 degrees Celsius per minute, your experiment over. Same experiment if you do in 2.5, you need almost 3 hours, 2.5 hours to 3 hours. Person is waiting 2 hours more, electricity 2 hours more, liquid nitrogen 2 hours more. Result is better. Why? Thermal lag will not be there, thermal equilibrium will be there. This is about mass. Polystyrene 20 milligram, 10 milligram, 5 milligram and 2.5 milligram. Same heating rate. Heating rate is not mentioned here. Let's say 5 degrees Celsius per minute. Same heating rate, same instrument. Sample they have taken more. Ideal sample weight. Why 5? What could remember? Fan should cover and it should be as thin layer as possible. That means sample has to be crystalline or sample has to be, if it is amorphous, it's like a hill. Big hill, small hill, dumped. You will get wrong result. Why? Thermal equilibrium will not be there. Surface will be hotter and inside would be less. Your answer is wrong. What is the best way? Not 2.5 milligram, 5 milligram or 10 milligram. It depends on the surface area of the pan. Pan should be covered thin layer as possible. That is the exact sample weight. If you have a hill kind of thing, more layers, what will happen? Again thermal lag. You don't reach the real temperature what you want. It takes time and instrument is running. It's okay. It's like you are traveling in your friend's car. Your friend doesn't know your destination. He knows vaguely and he is going at 120 speed. At 120 speed. You wait until Satyabama University come. Satyabama University came. By the time you say, he reached 2 kilometers far. Highway, not in this road. You are getting my point? By the time the sample realizes my TD came, your instrument is gone. So that's what it's needed. Let me close here. DSC, TGA we will not take. Now let me, wait. I'm ready to take some questions. If you want, I can leave the, what you call this one, here. You give my pen drive, okay, later on. But keep the presentation, you can see. Capacity, it can retain heat for longer, so your actual measuring temperature will change. Chances of error 1, based on the heat capacity of the pan. 2, radiation Your heating is happening through radiation, but it is only heating the outer layer into the inner layers. Where you are measuring is here. By the time it reach, here it is very large, here it is less, here it is less, here it is less, here less. You cannot measure actual temperature. Error 2. The third one, convection through the surroundings. It is keep on making you to the carrier gas to flow the decomposed product, but it is also cooling you because your carrier gas is at room temperature. Error 3. And the last one, this heating, cooling heat, it is not even understanding. 4 times 4 people are killing. Wife is telling something, son is telling something, mother is telling something, and the boss called, hey, are you coming or not? Yeah. Life. Okay? If it is not less minimized, less compromised, instrument charges are less. So, we must understand what is happening inside. Let me now close this by saying thank you all for your patience.
Now, queries.
Human mind works negative. What do you like? If I ask, you don't know. Okay, what didn't you like? You tell me, then I will say. Anybody? Please.
Flow rate of the gas will affect the...
Yes, sir, it will affect. If it is too low, it will not do its job of carrying away the decomposed product. So, decomposed product may settle back in the sample or may stick in the instrument. In the long run, instrument will go bad. But if it is more than the adequate, faster, it will cool the sample and it will again go problem. So, it has to be set as right flow rate. Usually 50 cc per minute is okay. And it has to be inert. If your flow gas is compromised quality, that will create another problem. Your TD, second sample you again run very fast up to 100 degrees. Let's say your TD is 500. How you know? Because you run 20 degrees Celsius per minute and 500. Because you don't want to lose money and time. The second time also you ramp up to 400 and then you do very slow. This is also another method, but you have to do 2 times. This also will tell you where is the closest answer and what could be the right answer. There are many ways people do. With experience they come up with many things. If your sample TD is 500, why you start from very slow from 30 degrees Celsius? Is waste of money, resources. Isn't it? Other questions? Yeah, because most of the weight loss is in a gaseous form. Because if it is decomposed, it will remain in the balance. So what kind of gases are mostly? It is H2O, C or other kind of low molecular weight gases. So if we know how much this is come in addition to our carrier gas, that also can be quantified or characterized. That's what I told. Evolved gas analysis. Yes. So the sample weight should be optimum. Just bare minimum to fill the pan with as single layer as possible. So that means your sample should be in a powder format or crystalline format and very thin layer. Little bit loud. That's why you have to do 2 times. First is very fast running. You will get a simple idea, provided that you have adequate sample. Sometimes what happens, your sample is very expensive. You don't know. And that kind of times, literature values will help you. You should have an idea, if this kind of samples are there, what could be. That's where DSC we never do first. We do TGA first and then DSC we do second. DSC we never do first. We do TGA first and then DSC we do second, because we know at what temperature. Research in my own paper, we have tried even research in my own paper. We have tried even 0.1 degree. Our sample runs whole night. You can imagine how expensive it would be. It depends what you want. There are sometimes solid transitions are there, especially in DSC. So all these small changes will help you to understand so well about the space arrangements and the sample. Do Celsius per minute is mostly acceptable. But if you do not have time, people go 10 degrees Celsius per minute. Only for PG experimentation, we go 20 degree. Otherwise, it is not at all recommended. 10 degree to give a rough idea. 5 degree, most of the people use in the literatures and research articles. But your research itself is on thermodynamics and thermal, then people go even up to 0.1. 5 degree is largely good. Most of the people, except for research article, 5 degrees Celsius. TGA, it will be very difficult, because unless your heating rate is very small, you understand something is happening. But what is happening, then your TGA should be clubbed with mass.
So can't go to
Phase transition you cannot observe in TGA. DSC can help. DSC can help.
TGA, we will be hanging in few. We will be keeping. Is there any gravitational effect? Because while hanging, maintaining temperature and these conditions, mostly we will be using horizontal. It's the best weather horizontal.
I don't know. It depends on the how calibration has been done and whether you have a reference or not. So this effect can be nullified through calibration and through reference. Through gravitational, only to help that decomposed products is not stick there so quickly. Whereas in this one, decomposed product may again settle down there. That's to avoid, maybe better. But it
means in case of if you want to electrons sample, metallic or large cases, better.
Yeah, because each method has its own advantage and disadvantage, and in vertical case it depends whether you have a reference or not and how you calibrate, and if it is throughout the experiment, if your another influence or errors are there, it becomes systematic error, so you will understand how to remove that systematic error. Any other questions? Yes, please.
You mentioned that 7 graph.
Weight increase may be due to carrier gas is reacting with the sample and making some new byproduct, and that new byproduct may not be stable for longer time. Again, it is decomposing.
So my question is to observe
That's why while showing system, I say it's with that. Possible to tell that. Mostly we see C and D. D mostly.
so multi-stage only.
In most of the research, we see D. Any other questions? Last bench. Yeah, please.
Sir, if we begin half of the material, decomposition rate, we may have different decomposition.
It depends on how good mixing is. Otherwise, you will get two different humps. Even though if it is good mixing, still you may see two different humps, but maybe very close to each other. So everything depends on how mixing is. Here, how mixing in two terms, physical and chemical. It depends on physical mixing. Physical mixing may not affect that much. Still you see two clear hump, but any That means it has not become a good composite. It depends, because if it is a film kind of thing, it will not have a weight loss for quite. It's like a polymer then, like a polymer.
And DSC, and you have given much information on thermokinetics also, sir. It is a new field, we know that. Participants, thank you, sir. So on behalf of organizing committee and this thing, our management, we would like to present a motion to Ramesh Gardas, sir. Sir.
Yeah, thank you all. Thank you.
Thank you, sir. Thank you, sir. Thank you, sir.
देखो मेरा फोटो भी है.
Now we will be having our snacks outside. Please assemble within 5 or 10.